Or if you just want to take notes like usual, I'll try to give you some hints like I did yesterday about what types of problems will be on the test. So it is tomorrow, don't forget. I'll give those quizzes back to you at the end of class today, don't let me forget. But this is just 6-4 to 6-8, and these are, bless you, these are the exact sections from that quiz. So you'll get to see those here in a little bit. Now, starting all the way at 6-4, this was a pretty quick section. I may put up here in just a second a little rule that you'll want to remember in this section. But for now, the directions say, write each expression in radical form. Write each expression in radical form, and that just means you need to have a radical in your answer. So while we're doing this, here comes the rule that you'll want to remember. I'll try to put it down up here, kind of small, but we're talking about radical form right now. Here in a second, it'll say exponential form. So I think this was the rule that we had in our notes. If you have a to the m over n power, that is a rational exponent. Everything good back there? Okay, I'm taping. Hallie's gone. I told her I would tape my lesson. So do you guys want to say hi to Hallie while we're doing this? Everybody say hi. Hi. All right, good times. Okay, there we go. So here's our rule. A to the m over n is going to equal the nth root of a to the m power. Kind of confusing because m and n sound alike, but that's what we want to use right here with example 1. And we're going to use them with all of these problems. So number 1 says 5 to the 1/8 power. Bless you. 5 to the 1/8. Now in this problem, 5 is a, 1 is m, bless you, and n is 8. PowerPoint doesn't ever make the fraction exponents look very good, but that is a fraction exponent, or rational exponent as we called it. So number on the bottom of your fraction becomes the type of root, which means this is an 8th root, and the number on top of your fraction becomes the exponent underneath. Now for this type of problem, you would want to go ahead and simplify that. 5 to the first power is just 5. I wouldn't go any further than that because you really can't go any further than that. But 5 to the first, you can probably just put 5. Okay. Now you'll also have some going the other way where you have to write the expression in exponential form. So I think I've got 2 of these that will do, but we're still using that rule at the top. Write each expression in exponential form. So our answers should have exponents this time. Example 2, it's the square root of 29. Square root of 29. The 29 is going to be the a in this problem. I don't really see any other numbers though to put with it. So if we want to be technical here, 29 is the same as 29 to the first power. And a square root, we don't ever write the 2, we just assume it's there. So rewriting that, it would be 29 to the 1/2 power. I mentioned this when we first learned about it, but we really do need to remember that a square root always turns into a 1/2 power. A cube root would be a 1/3 power. A fourth root is a 1/4 power, and so on. We use those a lot later on in math. Now, one more of for fun. Number 3, it's the square root of b, but the whole thing to the 5th power. We can't really put it in this form yet because it's not really matching up to this exactly. So watch and kind of see what I did first here. There's probably a couple ways you could do this, but I replaced the square root of b with b to the 1/2 power. And then once I wrote it like this, we had a rule. It was called the power to a power rule. And anytime you take a power to a power, you have to multiply those exponents. So if you take 1/2 times 5, I guess you could think of the 5/1 if you wanted, but that just turns into b to the 5/2 power. So that's our answer in exponential form. I didn't even really use that rule at the top. I just did a couple other things and then it worked out. Okay, this is probably the only thing you need to expect from section 6.4, knowing how to go back and forth. Any questions about those? Looking good. Okay, moving on to 6.5. I think this was the section where we were solving radical equations. And so that's pretty much what our directions say. Solve each equation. We'll do 2 of them. And I think these were pretty good on our quiz, but there's one thing you have to remember. It's the very first thing you have to do. You have to get the radical by itself. So this is example 4. 10 minus the square root of 3x plus 7 equals 7. What would be my first step if I want to get this square root by itself? Yes, subtract 10. There is still a minus right here. So to get rid of that minus sign in our next step, we can just divide both sides by -1. And now it says square root of 3x plus 7 equals 3. If you have your notes from 6.5, we should have some steps in there that say, like step 1, get the radical by itself. Step 2, undo the radical. If it's a square root, to undo a square root, you have to square. And so I'm just going to do that to both sides. This right here was one of the most common mistakes on the quiz, forgetting to square that side. A lot of people squared this and brought down the 3x plus 7, but then left it equal to 3. You can't do that. Whatever you do to one side of an equation, you have to do to the other. So that is a 9. Then subtract the 7 and divide by 3. It's not a nice decimal, so you can leave that just as a fraction. Get the radical by itself first. Okay, now we'll try one more of these. And it's example 5. We've got square roots on both sides. The square root of 2a minus 5 equals the square root of a plus 2. Now, because both sides have a single square root, technically your radicals are by themselves, so you can get right to it and just square both sides. Now, that makes me remember something. On the quiz, we had something like this: square root of 2a minus 5 minus square root of a plus 2 equals 0. If that is how this problem was set up, you would not be able to square both of these right off the bat. You would have to add that second square root to the other side first. We had some like that in the notes, so you can go back and look at those. But once you get one on each side, then you can square both sides like we are up here. So again, you'll get your quizzes back in a little bit, but that's something you want to look out for. Now, square roots and squares just cancel, and you can just bring down what you had underneath. So I would subtract the A and then just add 5, and you'll get A equals 7. You can always check these. If you want to plug a 7 in right there and a 7 over there, you should get the same thing on both sides. Okey-doke. 6-5, I think, for the most part, was just all about solving radical equations. So main thing, you got to get the radical by itself first. Any questions about that? We're moving here. I'm going to go ahead and move on to 6-6. And I want to say there's a little bit more in this section, probably more than all the other sections. We were talking about functions, function operations, fog, and goff. We got a little bit to do here in 6-6. So take a look at our directions. We'll use these for 3 problems. It says let f of x equal x minus 1 and g of x equal x squared minus 4. Then perform each function operation and find the domain, bless you, of the result. I think a lot of people on the quiz forgot to write the domain. That was one thing I remembered. They did the operation part just fine, but forgot to state the domain. So think about your domain killers. First one, doesn't really matter which one's first, but one of them was the square root of a negative, which I don't think we ever run into. But then the other was dividing by 0. That was one that we did run into. Okie doke. So here's number 6. And the notation always looks kind of weird. F minus g of x. That is a fancy way of saying you're going to take f of x minus g of x. Here comes something else I want to tell you about your quiz. The f of x can just go right here, but you have to subtract g of x. And because g of x is a quantity, you really need to put that quantity in parentheses because the minus sign is going to go to both of those terms. A lot of people just put x minus 1 minus x squared minus 4, and then they don't end up with the same answer we do because by the time you distribute that negative, the back part is actually negative x squared plus 4. And so once I rearrange this a little bit and also combine a couple like terms, it should be negative x squared plus x plus 3. It's a good idea to put it in descending order, biggest power of x down to the smallest. Right, f minus g of x. Now, I don't think I have an addition problem because addition is usually pretty easy. You don't have to worry about any of that stuff with addition. So let's go ahead and do our domain. I've already got the box up there. Domain, unless there is a fraction or a square root, which you don't have either of those, domain is just going to be all real numbers. Okay, any questions on number 6? Good chance there'll be a subtraction on the test, so keep that in mind. Let's do a multiplication. Number 7, f times g of x. F times g of x. Okay, fancy way of saying f of x times g of x. Now, f of x is x minus 1. G of x is x squared minus 4. So what do we have to do when we multiply binomials? We FOIL. I'm going to go x times x squared, which is x cubed, x times negative 4, which is negative 4x. Inner terms, that gives me a negative x squared. And then last terms, that should be a plus 4. So again, the only thing I would fix there is the order. Let's put the negative x squared second and then the minus 4x plus 4. That's your answer to the first part. Don't forget domain, all real numbers. If there's no square root and no fraction, then it's going to be all real numbers. Looks pretty good. Now, one more example with these two functions. I want to do a division because this is where we'll have to think about our domain a little bit more. It says f divided by g of x. F divided by g of x. Well, fancy way of saying f of x divided by g of x. And it starts out real easy. I just need to put f of x on top, g of x on bottom. But remember, you never want to divide by 0. That will kill your domain. So to find the values of x that we're going to throw out, we're going to take the bottom, set it equal to 0, even though I don't really want it to equal 0. Set it equal to 0 temporarily and solve it for x. This is a little bit different because of the square, but there's probably 2, maybe more ways that you could solve this. You can factor that if you want using a difference of squares, or if you want to just add 4 to both sides and then square root both sides. We will have to put a plus or minus in front since we square rooted both sides. And so it turns out we have to throw out 2 values of x. We're going to say all real numbers except x equals plus or minus 2. It can be anything at all except positive 2 and negative 2. Looks pretty good. Any questions about that? Function operations. Okay. I'm going to go ahead and put back up here the little information we had about fog and goth. So I'll just put it all up here and you guys kind of decide which parts you want to put down. If you're making your cheat sheet, all of this might be good to put down. This was probably a weak area on the quiz, so this is definitely good to review right now. Fog is f of g of x. And what that means is you have to take g of x, plug it into f of x. I think I told you in class you always start with the function on the inside. Now goth is the other way around, g of f of x. So now we take f of x and plug it into g of x. Definitely going to see a little fog and goth on the test tomorrow. So We need to kind of remember how these are done. F of g of x and g of f of x. So for the next few examples, I'll just give you the two functions to work with. And then for each problem, it'll say which one you're trying to find. Okie doke. I'll go ahead here. If you didn't get all of that, it is in your notes. So f of x and g of x are up there. And the directions, I mean, if you want to leave off that first part, you probably could. It says use the following functions to find each value or expression. Use the following functions to find each value or expression. And f of x is x squared. G of x is x minus 1. So we'll use both of those for the next few problems. Number 9, are we all the way at number 9 already? That was quick. Number 9, fog. We want to figure out what f of g of x is. F of g of x. So take g of x, plug it into f of x. Take g of x, plug it into f of x. And so wherever I see x up here, it gets replaced with x minus 1. So it's no longer x squared. Now it's x minus 1 squared. And I would like for you to go ahead and simplify that as much as you can. So we'll have to write it out twice and then FOIL it real quick. That turns into x squared minus x minus another x. I went ahead and made that minus 2x. And then negative 1 times negative 1 is positive 1. That would be our answer for fog. Now, number 10. Now we need to find what goth is. So it's going the other way. G of f of x. G of f of x. Now I want to start with f of x, plug it in to g of x. So you're not multiplying anything. The x right here just totally disappears and it gets replaced with x squared. And there's really nothing else you can do to that. X squared minus 1, that's how we would leave it for goth. Now I want to do a couple more over here where it's not just fog or it's not just goth. I'm using different notation here, but brackets, parentheses, it all means the same thing. On number 11, we want to find fog of 1. Now I did give you 2 ways to do this, but because we already know what fog is, we can probably just take this answer from number 9 and replace the x's with 1's. Let's just say 1 squared minus 2 times 1 plus 1. That's probably the easiest way to do it since we know fog. Other way to do it is to find g of 1, plug it into f. That actually wouldn't have been too bad either. But this works out to be 1 minus 2 plus 1, which is just 0. And that's what I would have gotten using the other method. Okay, and last one of these, number 12, goth of A. It always seems to be confusing when it's a variable that you're plugging in, not just a number. But here again, it's nice because we already know what goth is. It's x squared minus 1. Replace the x with a, and now it's just a squared minus 1. If you plug in a number, you should get back a number. If you plug in a letter, you should get back a letter. Question.
Is that how it'll be on the test where we're already doing fogging off?
May not always match up like that. That's a good question. So if we didn't know what fog was up here, method 2 seemed to be a little bit easier if you didn't know what fog is. So this might be helpful to write down in case you don't know fog. F of G of 1 is the same as saying F of G of 1. We could just kind of write it like that. So the second option, if you don't already know fog, is to figure out what G of 1 is. And so that means I just need to plug a 1 in right here. 1 minus 1 is 0. Then I would take that 0, plug it into f of x, so 0 squared, that's also going to give me back a 0. So good question. If you don't know one of those from earlier, then you can always kind of go back and try method 2. Anybody else? Okay. Now, let me see here. We've been in 6-6 for a while. That's the last part that I'm going to review from 6-6. So 6-7, I'll put a couple examples up here of finding inverses. That was really the only thing that we learned in section 6-7. Now, I left off the easy ones where you've got the ordered pairs and you just switch the x's and the y's. I'm not saying that won't be on the test. It could be on the test. But for the review today, I'm going to try and focus on the ones that were a little bit harder. So, for example, number 13 on the day, h of x equals x minus 5 all over 2. You should have some steps in your notes about finding inverses, so that wouldn't be a bad thing to put on your cheat sheet for tomorrow. But first step was to replace that part with y. Then we switched x and y. So now it's going to say x equals y minus 5 all over 2. And pretty much the last thing to do here is just to solve that for y. And so what would my next step have to be? Multiply by 2. And make sure you know that the 2's over here just cross out. Don't distribute the 2 to what you had on top. You don't have to do that. You just bring that part down. Now add 5 to both sides and you get y equals 2x plus 5. If they give you some kind of function notation at the beginning, go ahead and use that little -1 that we had in the notes and write it as h inverse of x equals 2x plus 5. If they just give you y, though, you can leave it as y. All right, now I want to try one more of these, and then 6-8, that'll be it. Number 14, y equals 3x squared minus 2. This does just have y out front, so we can just leave our answer with y when we're finished. We do need to switch x and y, and then solve for y. So add 2. I hope we all know to do that first. Once I add 2 to both sides, what is my next step? Not quite square root yet. I would divide by 3 first, because you really want to get the y squared alone before you square root, because that's when the square and the square root can drop out Now what am I going to need in front of this big old square root? Plus or minus. So I switched that around and just wrote it as y equals plus or minus square root of x plus 2 over 3. On the quiz that you'll get back here in a little bit, you did have one with a square root. So make sure you don't leave off the plus or minus. Okay, last section here is 6-8. This is where we were graphing square root functions. And so I'm going to put back up here the parent graphs for each one. I mean, technically there's only one parent function. This is it. But we also looked at the graph of this flipped. And I'll go ahead and tell you, there is one on the test that is flipped. So having that part might also be helpful on your cheat sheet. This is just square root of x. That is negative square root of x. I think there's 2 of these total, so not very many, but I do remember one of them being flipped. So use this if it's not flipped, if there's no negative out front, and use that if there is a negative out front. Okay, and go ahead, question. There could be. We did have some of those in the notes. I think for the most part, it's just going to be moving left or right or up or down. If there is a dilation, you just want to make a little XY table, but I don't think you'll see that too much on the test. So speaking of moving around, I am going to put those rules back up here in case you're making a cheat sheet and you want to have these on there. So here they are. You can shorten them up however you want to, or like I said, if you're not doing a cheat sheet right now, you may not have to recopy all of them. They are in your notes, but we got to remember adding on the outside of a function moves it up, subtracting on the outside moves it down. The outside stuff, those usually make sense. When you do it on the inside, it's always backwards from what it seems like it should be. Adding on the inside moves it to the left, and subtracting on the inside moves it to the right. And then good question about the dilations. If there is a number in front of the square root, then you can just make an XY table, or if you have a graphing calculator, you can do it on there to see where your points will be. All right. So we're just going to try one today with the review, and it's kind of similar to one from the test because there is a negative out front. Y equals negative square root of x plus 4. We know the negative is going to flip it, but what will that plus 4 do? Move it to the left. So flipped left 4. If you remember where your parent function is, except this is the parent function flipped. But if you can remember where those 3 points are, on this problem, just take all 3 of those left 4. So there, and there, and there. Remember, it never gets level. It never goes straight across. It's still going to go down a little bit more the further out that you go. And there's only one arrow, not here, only one arrow down there at the bottom. Okay, so I didn't give you a review assignment yesterday, and I'm not going to give you a review assignment today, but study, obviously, make a cheat sheet that is kind of like an assignment. And I'll pass back your quizzes right now.